Most people think an operating system is just something that helps us run the apps. But from a security point of view, the operating system is actually a protector. Almost every major vulnerability, exploit, or malware you hear about is somehow related to operating system. So before talking about hacking or defense, we must understand what the OS is protecting in the first place. In this video, I'll explain what the OS protects, why it is a trust boundary, and why attackers mostly target the OS instead of applications. At the very basic level, OS sits between application and hardware. Applications are not allowed to directly touch the CPU, memory, disk, or network. The OS decides who can do that. So the OS controls CPU usage, memory access, file access, device access, and permissions. From a security angle, this means the OS enforces the rules. Without an OS, every program could do anything, read anyone's data, overwrite memories, or crash the system itself. In security, a trust boundary is a line where trust changes. The OS creates one of the most important trust boundaries in the system. On one side, you have applications. On the other side, you have the operating system itself. The OS assumes applications are not trusted at all, but the OS kernel is trusted. This boundary exists because applications can be buggy, malicious, or compromised. So the operating system says, I don't trust you, but I allow you to do limited things safely. This idea alone explains why OS security exists. Now let's talk about user space and kernel space and what this is actually. The enforce to enforce this trust boundary, the OS separates execution into two spaces. First one is user space and the second one is kernel space. User space is where applications run. Kernel space is where operating system core runs. Applications in user spaces have limited privileges and they cannot access hardware directly and cannot access other apps memory also. But in the kernel space, they have full control and they can access hardware, manages memory, CPU files and devices. And if an application crashes in user space, it usually affects only that particular app. But if something crashes in kernel space, the entire system can freeze or reboot. So this can be dangerous. This is why kernel code is extremely sensitive from a security perspective. So why does the operating system need to protect apps from each other? Imagine you have multiple apps running. You have a browser, then you have a password manager, and then you have a music player. And if there were no operating system level protection, one app could read another app's memory. One app could steal passwords. One app could crash the entire system itself. The operating system prevents this by isolating applications. This isolation is one of the core security responsibility of an operating system. And why most of the exploit target the operating system? Attackers usually don't want to just crash an app. They want control. And applications are heavily restricted by operating system. So attackers try to break out the user space, cross the trust boundary, and gain the kernel level privileges. And if an attacker manages to exploit a bug in the operating system, they can bypass security checks, all the security checks, access sensitive data, disable the protections that we have, and hide the malware there. That's why we see terms like privilege escalation, kernel exploits, driver vulnerabilities. These are some dangerous attacks. One of, Once the operating system is compromised, every apps become compromised. Think of an OS as a security gate in a building. Employees are applications. The server room is the hardware. Employees are allowed to work only in a certain areas. Security controls who can go where. And if someone tricks security and gets the master access and they can enter any room. That's exactly happen when attackers break operating system protections. They have the master access if they can exploit operating system level protections. The operating system is not just an software that runs app. It is a true enforcer, a protector, and the main security boundary of the system. Understanding operating system security starts with understanding what OS is trying to protect. So in the next video, we'll go deeper and understand how programs actually run, what processes and threads are, how execution happens, and why crashes and race conditions become security issue. And once you understand that, many real world vulnerabilities will start making sense. Remember, we keep it simple.